Hello students, welcome back to the channel. So this is the continuation of classes on the topic amino acids and proteins. In this video, we shall give importance for chemical properties of amino acids. So we know that amino acids are the materials which are having the general molecular formulae CH, COOH, and here there will be a side chain and one NH2 group. So we used to call these materials as alpha amino acids, right? So we know the reason that each functional group is present at alpha position with respect to the other functional group. That is the reason why we used to call the amino acids as alpha amino acids. And if you come to the case of chemical reactions or chemical properties of the amino acids, the chemical reactivity of the amino acids are due to the functional groups that are present in the amino acid, that is carboxylic group and amine group. And we know that if you know the detailed structures of all the 20 naturally occurring amino acids, in the side chain also we will be having the functional group in some cases of the amino acids. Like in case of aspartic acid, we are having COOH. In case of glutamic acid also we are having COOH. And in case of aspargine and glutamine, we will be having NH2 group. Right? So like this, in side chain also we will be having the functional group. So the chemical reactivity of the amino acids are mainly due to NH2 group, or it may be due to COOH group, or in some cases the chemical reactivity of the amino acids are due to both the functional groups, that is both NH2 as well as COOH. And in some cases, the chemical reactivity of these amino acids are due to the functional group that is present in side chain also. So if you want to go for the chemical reactions of the amino acids, we need to focus individually on the chemical reactions of NH2, chemical reactions due to COOH, chemical reactions due to both, and chemical reactions due to the functional group present in side chain. Therefore, we shall give the importance and we shall look over the different kinds of chemical reactions that an amino acid possesses because of either of the functional group. So now we shall proceed further about the chemical reactions of amino acids. But in this session, we shall restrict ourselves only for the chemical reactions which is due to NH2 group, and we shall look over the chemical reactions of amino acids due to COOH and side chain functional group in the next video, which will be uploaded in very short time after this video. Under the chemical reactions of amino acids due to NH2 group, the first reaction is the reaction of amino acid with an acid. Since we know that the NH2 group is a basic component, so when you react one such base component with an acid, the resulting compound will be obviously a salt material. So we can say that when an amino acid is reacted with an acid, the NH2 group of the amino acid will react with acid, and that results in the formation of salt. So we can call this reaction as the reaction salt formation. So now we shall see how the reaction will occur with amino acid and acid. If you consider an amino acid that reacts with a normal mineral acid, that is HCl preferably, we are not going with H2SO4 or HNO3. The reason for not using H2SO4 or HNO3 to react with amino acid is that the sulfuric acid and nitric acid are very strong oxidizing agents, as well as they are the charring agents. So that since the amino acids are biomolecules which can readily undergo charring in presence of strong oxidizing agents such as nitric acid and sulfuric acid. So we are not going to use sulfuric acid and nitric acid. Instead, we use only hydrochloric acid. So now we shall see the reaction pathway for the reaction between amino acid and hydrochloric acid. So if you consider a simplest general equation for this reaction, so it will be CH side chain R, COOH, the carboxylic end, and NH2, right? So we'll take one hydrogen over here. So that we'll be treating with HCl. So H plus and Cl minus. So we know that there will be a lone pair of electrons on the nitrogen atom, and these lone pairs will be donated to the electron deficient H plus, and that results in the formation of COOH, CH, the side chain will be there. NH2 will converts into NH3, and due to loss of lone pairs, nitrogen will attain the positive charge. To counterpart this positive charge, the Cl minus will come over here. So when amino acid reacts with HCl, it results in the formation of the salt of amino acid, right? It is the salt of amino acid. So we can take one simple example to illustrate the reaction of amino acid with hydrochloric acid. So here, let me consider the simplest amino acid, that is glycine. So when glycine made to react with hydrochloric acid, HCl, the same thing will happen, that is donation of lone pair of electrons to the H plus, so that it will be results in the formation of CH, and here it will be H, and NH3 with a positive charge on nitrogen, and counterparting ion Cl minus. So here the amino acid I have taken is glycine, and this is the hydrochloric acid. The resulting material is glycine hydrochloride, and here you can notice, so when you react glycine with hydrochloric acid, none of the component is eliminating, whole and solely HCl is added on to the glycine. So it is an addition compound, so we are calling this as glycine hydrochloride. If at all, if you use another material such as alanine, the resulting material will be alanine hydrochloride. Like this, the material will form, and all these are the salts of the corresponding amino acid which are produced by reacting with this mineral acid. The second reaction is reaction of amino acid with formaldehyde. So formaldehyde will be having the formulae HC double bond OH. This is the formaldehyde, and we can react this with an amino acid CH, NH2, the side chain, and COOH. Right. So when amino acid is made to react with formaldehyde, you can notice there is a doubly bonded oxygen atom over here. So the two hydrogen atoms present in the amine group will combine with the oxygen atom of this formaldehyde, and that results in the elimination of water, so that it will be results in the formation of COOH, CH, or N, and this double bond will remain. C, two hydrogen atoms are there, so you can write it as CH2. So you can observe in this compound we are having CH2. We know that the CH2 group is simply called as methylene, and this methylene group is in attachment with nitrogen of this amino acid. So we can call it as N-methylene, and this is the acid, right? So it is N-methylene amino acid is the product we are going to get when you react an amino acid with formaldehyde, right? So by this reaction, it is easier to see the methylene substituted compounds of amino acids. So we shall take one simple example so as to show the reaction between amino acid and formaldehyde. So this time let me consider the amino acid, that is alanine. When alanine is made to react with formaldehyde, so formaldehyde can be simply written as CH2 double bond O. This is the condensed way of writing formaldehyde. So in presence of formaldehyde, the same thing, the water molecule will get eliminates, and that results in the formation of a condensation product COOH, CH, CH3, N double bond CH2. So at N position we have a methylene group, and the parental amino acid is alanine. So we can simply write the name of this material as N-methylene. The amino acid is alanine. So the name of the compound produced is N-methylene alanine. So this is the simplest way that we can illustrate how the amino acid will react with formaldehyde. So we can get one doubt over here. Here I have considered only formaldehyde, which is the first member of the aldehyde group. But the question that comes to our mind is how an amino acid is going to react with an aldehyde other than formaldehyde. So the reaction of amino acids with aldehyde other than formaldehyde is very important, and that we shall look over now and shall see what is the significance of that reaction. Now we shall see the reaction of amino acids with aldehydes other than formaldehyde. So if you consider a simplest amino acid with the general molecular formulae are CH, NH2 and COOH. The simplest general molecular formula for amino acid, and now we shall react this amino acid with an aldehyde other than formaldehyde. So R dash C double bond OH. So this will be aldehyde other than formaldehyde, right? So here R dash can be either an alkyl group or it can be an aryl group. Okay, so same thing will happen. H2 will combine with this hydrogen so that it results in the elimination of water molecule. But do remember in the mind that the reaction will get reverse exactly when you add the water molecule. So if water molecule get eliminates, you are going to get a product. But if the same water molecule is added, you will get the two products separately once again. So the reaction is reversible in nature. But now we shall see what the product is going to get when one molecule of water is eliminated upon the reaction of amino acid with an aldehyde other than formaldehyde. So R, CH, COOH, and this will be in combination with N, double bond, CH, and here it will be R dash, right? So this is a simple material called as Schiff's basis. So hope you remember in organic qualitative analysis we use a material by name Schiff's base or Schiff's reagent, right? So the Schiff's base or Schiff's reagent will be used in this way and will be used as a catalyst, or even it can be used as a dye material also for coloring the polymeric material. In that way, this Schiff's base is having a great importance. So we shall make one simple example to illustrate the reaction of aldehydes with aldehydes other than formaldehyde. Let us consider the amino acid that is valine. So when it is reacts with acetaldehyde, which is having the formula CH3C double bond OH, upon reaction of valine with acetaldehyde or simply ethanol, same thing, the H2 will eliminate with the oxygen which is doubly bonded with carbon. So elimination of water will occur, and as I said, the reaction is reversible with H2O. So we are going to get CH3, CH, again CH3 over here, CH, COOH, and N double bond CH, CH3. So this is the compound we are going to get when react with ethanol and valine. So this is once again a variety of Schiff's base which can be used as a good dye material for coloring the polymeric materials. And this is how an amino acid reacts with aldehyde other than formaldehyde. Next is the reaction of amino acids with alkyl halides. So we shall see how the reaction will occur when you perform a reaction between alkyl halides, that is haloalkanes, with that of amino acids. So this is the amino acid. NH2 has been written as NH and one H has been stickered like this. And now we shall place one alkyl halide. So R-Cl has been taken, and now the simplest reaction is lone pair of electrons present on the alkyl chloride. Here I have taken chlorine. So this lone pair of electrons will be donated to the hydrogen. So the bond pair of electrons is not necessary for this hydrogen to bind up with nitrogen. So these two will shift on to nitrogen, creating one electron rich center, and that electron rich center is about to bond with some other component which is having electron deficiency. And if you observe, when these lone pairs comes to the H, there occurs a bond between H and Cl, but chlorine can have only one bond, and here one lone pair is lost. In order to recreate that lone pair, the bond pairs will shift on to the chlorine. So bond between R and Cl got broken, so that the lone pair of electrons which is present on the nitrogen will be donated to this alkyl group, so that the amino acid will get alkylated when it is reacted with alkyl halide, and that results in the formation of a product whose structural formula will be written like this: R NH2 will turns to NH, and that will be in attachment with R dash. So here the nitrogen is alkylated. So we can simply write as N alkyl, and the parental material is amino acid. This is the material which is going to produce when amino acid is made to react with alkyl halide. Clearly we can say it is the process of alkylation of amino acids. Now we shall look over about one small illustration by considering one simple example. Here I have taken the example of a reaction of serine with that of methyl chloride, or simply we can call it as chloromethane, right? So when you react these two materials, same thing, the H and Cl will combine, and that results in the elimination of HCl. HCl is going to eliminate, and the resulting condensation product will be OH, CH2, CH, COOH, and here the NH will be in attachment with CH3. So serine is got methylated, so name of the material will be N-methyl, and the amino acid is serine. This is the way how we can perform a reaction between amino acid and alkyl chloride or alkyl halide, anything it can be, to make the amino acid alkylated. So in the last reaction we saw that when amino acid is made to react with alkyl halide, it results in the formation of corresponding alkylated amino acid. It is a continuation of the reactions of amino acids. Instead of reacting an amino acid with alkyl halide, we are going to react with either acid chlorides or with acid anhydride. So that if you react with acid chlorides and acid anhydride, an amino acid is going to be acylated, and thus this reaction is simply called as acylation reaction of the amino acid. We know that if any material is substituted with this particular component, which is called as acyl group, the reaction is simply called as acylation. And depending upon this nature of or type of the R group, the reactions will be called differently. Suppose if the R group is a CH3, then it will be called as acetylation. If it is the benzene ring, that is C6H5, then it will be called as benzoylation, like this. So now we shall observe the acylation reactions of amino acids. Okay, let us consider the reaction of this amino acid. So once again I will be writing the amino acid in this way: R COOH, the acidic group. So when you react with acyl group, especially with acid chloride, so acid chloride can be simply written as ClCO dash, that is RCOCl is the simplest way of writing acid chloride. When acid chloride is made to react with an amino acid, same thing, the Cl will release the H content from this amino acid, and this lone pair of electron present will be donated to this carbon atom by shifting these bond pairs onto the nitrogen. So there develops a bond between this nitrogen and this carbonyl group, and that results in the formation of COH, CH, R, N, H, single bond, C, double bond, O, R dash, right? So this is the acyl group that has been substituted to the amino acid. So we can say that the amino acid is acylated and it is present at the nitrogen atom. So as how we said in case of last reaction, N-alkyl amino acid, so it is N-acyl amino acid is a product we are going to get when an amino acid is acylated. Now we shall consider one simple example of an amino acid and reaction of it with acid chloride. So here the amino acid that we are considering for the illustration is leucine. When leucine is reacted with acid chloride, so let me consider benzoyl chloride. So Cl, C double bond O, benzoyl, in the sense at the place of R we are supposed to take C6H5. The same thing, Cl will eliminate the H in the form of HCl, and that results in the formation of and now the lone pair of electrons will donate to the carbonyl group and these bond pairs will shift on to nitrogen. So they develop a bond between nitrogen and this carbonyl group. So the resulting material will be CH2, CH, CH3, CH3, CH, NH, C double bond O, C6H5, and here there will be COOH. This is the material we are going to get, and this is the derivative of the amino acid leucine, wherein at nitrogen atom we are having benzoyl group. So name of the material is N-benzoyl. The amino acid is leucine. That's the name of the material. And now we shall proceed further under the same heading, that is acylation of amino acids. Instead of using acid chloride, we can go with acid anhydride. And now we shall observe how the reaction is going to happen and what are the byproducts is going to produce. Here, for the purpose of acylation reaction of amino acid, I have taken glycine as the example, and the acetic anhydride is going to be treated with glycine so as to perform the acylation reaction. And here what will happen, the lone pair of electrons present on the oxygen atom will actually receive this hydrogen. So the lone pair of electrons present on the nitrogen will be donated to this carbonyl, and to balance this lone pairs, these bond pairs will shift on to oxygen, and to balance this lone pair, this bond pair will shift on to nitrogen. So that there occurs breaking of bond between nitrogen and hydrogen over here, as well as the bond get broken between carbon and oxygen. So a new bond will form between this nitrogen and carbon. And now we shall see the product which is going to be produced: COOH, CH, H, NH, and C double bond O, CH3, right? So here this group that is attached is the acetyl group. So we can say here the glycine is acetylated, which is generalized as acylated. And now the material which is going to produce as a byproduct in this reaction is CH3COO. Upon accepting this hydrogen, it's going to eliminate CH3COOH. So acetic acid is going to eliminate, and name of this material will be, the substituted material is acetyl group. So it is N-acetyl, and the amino acid taken is glycine. So the name of the material is N-acetyl glycine. So that's about acylation reaction of the amino acids. Next reaction is the reaction of amino acid with nitrous acid. We know the formula for nitrous acid is HNO2. And we know that nitrous acid cannot be stored in bottles. It is supposed to be prepared instantly when it is required. So in order to prepare the nitrous acid instantly in situ, we have to react NaNO2, that is sodium nitrite, with the hydrochloric acid, that is HCl, under a temperature of 0 to 5 degree Celsius. At this particular temperature, instantly sodium nitrate will react with HCl so as to eliminate NaCl, so as to produce HNO2 with the expulsion of NaCl. And this HNO2 is having the simplest formula as OH N double bond O. So this is the simplest way of writing the complete structure of the nitrous acid. Now we shall look over how this nitrous acid is going to react with amino acid. Let me consider the glycine as a direct example for performing a reaction between nitrous acid. Okay, so COOH group will remain undisturbed, and this NH2 amino group is actually going to interact with this nitrous acid. So nitrous acid is having the structure N double bond OOH. So these two hydrogens will combine with this oxygen, and that results in the elimination of H2O. And there develops a bond between nitrogen and nitrogen. So you will get COOH, CH2, N double bond NOH. An intermediate compound will be produced. And this intermediate compound will undergo further manipulations in such a way, so you can say that on each nitrogen atom there will be lone pair of electrons, because here the nitrogen valency is completely satisfied, right? So in order to make a new bond, the lone pair of electrons present on one of the nitrogen will shift between the two nitrogen atoms. So there develops a triple bond. In order to balance these lone pairs, the bond pair of electrons present between carbon and nitrogen will shift on to nitrogen, making this carbon atom electron deficient. Okay, so to balance this electron density, the lone pair of electrons present on the oxygen atom will be donated over here. Again, the same thing, to balance the lone pairs, bond pairs will shift on to oxygen. So here, once again, you can observe the bond is getting broken over here as well as here. And you can observe there are two nitrogen atoms combines together, and that results in the elimination of nitrogen gas. The resulting compound will be COOH and CH2, and at the place of N we are observing the presence of OH, right? So completely the amino group is eliminated. At the place of amino group we are placing the OH group. So an amino acid upon reaction with nitrous acid results in the formation of a hydroxy carboxylic acid. I repeat, when a amino acid, here in this case glycine, when treated with nitrous acid, it results in the formation of a hydroxy carboxylic acid. And in this case, the hydroxy carboxylic acid produced can be given with two names. One is the common name and other one will be the IUPAC name. In common name, this material is simply called as glycolic acid, since it is produced from the amino acid glycine. And in IUPAC system, we can say it is 1, 2. At second position, we are having OH group. So it is 2-hydroxy. There are two carbon atoms in the parental chain, so it is ethane, and since it is a carboxylic acid, so we can call it as oic acid. So full name of this material is 2-hydroxy ethanoic acid, or simply glycolic acid. Reaction of amino acids due to NH2 group is oxidative deamination of amino acids. See, in case of this particular reaction, the heading itself giving you some information. It is oxidative deamination. Means we are going to perform oxidation as well as we are performing deamination. Means we are going to remove the amine group of the amino acid. So once you remove the amino group, the product which is going to produce will be completely different from the amino acid. Now we shall see how the reaction is going to proceed when you react an amino acid or when you subject an amino acid for the process of oxidative deamination. And do remember, in order to perform the oxidative deamination of an amino acid, we need to place a particular enzyme which are simply called as deaminases. These are the class of enzymes that can be used for performing oxidative deamination. So for instantly, let us consider one amino acid in order to perform oxidative deamination. So oxidation, obviously nascent oxygen is required, and here the amino acid is taken in general way. So the amino acid deamination procedure will be performed in presence of enzyme deaminase. In presence of this enzyme, the NH2 group which is present in the amino acid will pick the alpha hydrogen, and that results in elimination of NH3, that is ammonia, which will be further used in urea cycle. And after removal of this NH2, oxygen will bind up, and that results in the formation of C double bond OR. So this is alpha position. At alpha position we are having a ketonic group, that is carbonyl group, and thus we used to call this as alpha keto acid. Strictly speaking, alpha keto carboxylic acid. And now we shall observe one example for oxidative deamination. Now here we have considered an amino acid which is isoleucine. When isoleucine is subjected for the process of oxidation in presence of a suitable enzyme, and the enzyme that is should be used is, it is isoleucine deaminase, the corresponding enzyme which perform the deamination reaction of the amino acid isoleucine. In presence of this enzyme, the same thing, NH2 will pick the alpha hydrogen, and that results in the elimination of ammonia, and the resulting material will be CH2, CH3, CH, again CH3, C double bond O, COOH. So this is the material we are going to get. So alpha position is having ketonic group, right? So alpha keto corresponding acid, or else after removal of NH3, this is the material we are going to get, wherein at alpha position we are having keto group. Or in case of IUPAC system, 1, 2, 3, 4, 5. Parental chain is having 5 carbon atoms, and at third position we are having a substituent, that is methyl group, and at second position we are having a ketonic group. But here this is not ketone, we used to consider this as a substituent, so it should be called as 2-oxo and 3-methyl, and there are 5 carbon atoms in the parent chain, so it is pentanoic acid. This is the IUPAC name of this material, which is produced when isoleucine is deaminated. That's about deamination, in a strictly speaking way, oxidative deamination of amino acids. This reaction is transamination reaction. The point itself, the heading itself telling you it is transamination, means there occurs transfer of amino group, transfer of NH2 group from an amino acid. But the question that comes to our mind, okay, we are transferring NH2 group, but to which material we are transferring? To where we are transferring this NH2 group? The transfer of NH2 group will be performed to a alpha keto acid. Just in the previous reaction only we observed, when a amino acid is subjected to oxidative deamination, we are going to get an alpha keto acid. If you react that alpha keto acid with another amino acid, the amino group present in the amino acid will be transferred to that alpha keto acid. And now we shall see what the reaction is going to result. Okay, so let us consider one simple general reaction. The amino acid can be written in this way: CRH, COOH, and here it will be NH2. So this is the amino acid, and this will be reacted with an alpha keto acid. Let me consider R dash C double bond O COOH. So this is alpha keto acid. Okay, or else in order to avoid the confusion, let me consider this as R1 and R2. Fine. So when you perform this reaction in presence of an enzyme called transferase. Transferase is the enzyme, but the reaction is reversible in nature. When amino acid is reacted with alpha keto acid, just you observe the transfer of this NH2 group, this alpha keto acid. So the reaction will produce in this way: C H NH2 COOH and R2 plus R1 C double bond O COOH. So this is the product of the reaction. You can observe, in case of amino acid, the side chain is R1, but here in this case the side chain is R2, and in case of alpha keto acid the alkyl group is R2, but here it is R1. In the sense, when one amino acid is made to react with an alpha keto acid, that results in the formation of a new amino acid and the corresponding alpha keto acid. This is a very important reaction. That means whenever the system requires a particular amino acid, instantly the oxidative deamination and the transamination will occur very rapidly to supply the needy amino acid for the synthesis of protein. Now we shall consider one simple example so as to illustrate the transamination reaction. Let us consider the simplest amino acid, that is glycine. Okay, so glycine is having the simplest formulae like this, and here I am going to react glycine with an alpha keto acid, provided the side chain will be CH3 COOH and double bond O. Right, so this is 2-oxopropanoic acid. Since we are having 1, 2, 3 carbon atoms, right? So it is 2-oxopropanoic acid is the alpha keto acid we got, and that we are reacting with glycine in presence of the enzyme transferase. In presence of this enzyme, this NH2 will transfer to this alpha 2-oxopropanoic acid, and now we shall see what the product is going to produce. NH2, and here it will be COOH, and there will be H, and here it will be CH3, and now the alpha keto acid is going to produce is C double bond O COOH, and here it will be H. Right, so we started with glycine and reacted with 2-oxopropanoic acid, and that results in the formation of glycine is converted into alanine, and 2-oxopropanoic acid has been changed to 2-oxoethanoic acid. Right, the corresponding alpha keto acid we got over here. Right. So alanine is the new amino acid produced when we perform a transamination reaction of glycine with 2-oxopropanoic acid. And depending upon the chain of the corresponding alpha keto acid, we are going to get necessary or the other amino acid. And that's about the whole transamination reaction. That's all about the chemical reactions of amino acids, which is due to NH2 group. And now we shall proceed further in our next session about the chemical reactions of amino acids due to COOH group, which will be posted very soon. Thank you.